Okay, in this, the fourth part of our environmental health unit, I'd like to talk about three ways that low-level exposure to toxicants can result in disease. And I'd like to explore these in a little more detail and give you some examples of how we have seen these effects occur. Toxicants at low ambient levels most commonly affect human health in these three ways. One, as endocrine system disruptors. The endocrine system is that system of hormones in your body. And so there are chemicals that can disrupt that system from working. We'll talk about the endocrine system and what that might look like. Second, there are immune system modulators. The immune system protects you from all sorts of disease and foreign invasion. And there are chemicals that can change the activity of the immune system, both stimulate it and reduce its ability to act. And we'll talk about that. And finally, we're going to talk about carcinogens, which are chemicals that cause the mutations that cause cancer to occur. So let's look at each of these. What is the endocrine system? Well, here I've got a picture of some of the components of the endocrine system. The endocrine system is a system of glands in the body that produce chemical messengers, and those messengers are known as hormones, and they travel through the bloodstream to other parts of the bodies, and they signal certain other cells to do something. Hormones occur in very low concentrations in the body because only certain cells will respond to them, and those cells have receptors that recognize those hormones. So they do not need to be around in high concentrations. And just to talk about what the endocrine system does in general, it regulates development, which is the process by which a fertilized egg differentiates into the body of an infant that is born. It regulates growth from infancy to adulthood. It regulates metabolism, the rate at which you carry out chemical reactions in your cells. And in the human body, it regulates things like blood sugar level and basal metabolic rate. And it regulates sexual development, which is maturation from immature to mature or adult state, and function, the production of gametes. So as you can see, the endocrine system does a lot of important things, and you can imagine what it might look like if it gets tampered with. Now, endocrine disruptors are chemicals that interfere with the actions of hormones in humans and wildlife. Examples are abundant, and they include chemicals, some of which we've heard of, such as PCBs, polychlorinated biphenyls, we talked about earlier, dioxins, we'll talk more about later, DDT, the pesticide that caused the decrease in population of the bald eagle, heavy metals such as lead and mercury, which we'll talk more about in the water pollution unit, PBDE, a flame retardant, which are members of the organobromine class, and we talked about those when we saw the film on climate change, phthalates, which we're going to talk more about in a little bit, and bisphenol A or BPA, which are used in certain plastics and you may have heard about. Since hormones occur in low concentrations in the body, very small exposure from environmental sources, especially when chronic, can have a large effect on the endocrine system. How do they work? Well, basically, any way you could imagine that they could change the endocrine system, we have examples that they do. So some chemicals mimic a hormone and cause the cells in the body to respond to a mimicked hormone. Some block the effect of the hormone, so the body is producing a hormone and the body's not responding because the hormone is being blocked from doing its job. And some inhibit or stimulate endocrine system, so make the endocrine system put out more hormone or put out less hormone. As I said, if you can imagine a way that a chemical might affect the endocrine system, it's probably occurred. Animal studies have shown that exposure can lead to altered reproductive development and sterility. So let's look at some examples from the real world where endocrine disruptors had an effect. The first one was a spill into Lake Apopka, Florida of DDT in 1980. And as you can see here, the population of alligators plummeted in Lake Apopka for about 15 years or so. And what happened was male alligators had low levels of testosterone from the exposure to DDT. They had high estrogen levels. Their reproductive organs were feminized, and they were unable to reproduce as effectively. And that resulted in a decrease in the population of alligators. Now, you may say, so what? These are just alligators. But the point is, if it's happening in alligators, the effects in humans are probably also happening. These are the so-called canaries in the coal mine, or alligators in the lake, if you will. Some other examples. In the 1950s and 1960s, certain women who were pregnant were given a drug called DES, diethylstilbestrol, to prevent miscarriage. And when the daughters of these women were looked at, there was an increased incidence of reproductive system birth defects and an increased incidence of vaginal cancer later in life. So here is an example of a chemical that acted as an endocrine system antagonist and caused birth defects and increased cancer later in life. Fish in the Great Lakes that have high exposure to PCBs have a high rate of reproductive problems. And so the fish that are eating these birds have similar reproductive problems, showing you that these chemicals can affect the endocrine system. And finally, in a very famous experiment from a lab, male frogs were exposed to the herbicide atrazine, and they were feminized. They ended up looking more like females and had decreased ability to produce male gametes. Those are some examples of the kinds of things that have been observed. One thing we can say in humans is infertility is increasing, and hormonally related cancers such as breast cancer and testicular cancer are rising. Those phenomena are possibly explained by an increase of exposure to endocrine disruptors in the environment. I want to just talk to you a little bit about phthalates for a second. Phthalates are synthetic chemicals that are used to make plastics harder to break because they become more flexible. They're called plasticizers. They are used in thousands of products, including cosmetics, fragrances, soaps, nail polish, medications, toys, food packaging, etc., etc. Human health effects of phthalates are unknown, but they have been implicated as endocrine disruptors. The good news with phthalates is they do not seem to bioaccumulate. In the past few years, researchers have linked phthalates to asthma, to ADHD, to breast cancer, to obesity, to type 2 diabetes, to low IQ, to neurological development issues, to behavioral issues, autism spectrum disorders, altered reproductive development, and male fertility issues. And these are chemicals that we are all exposed to on a regular basis and can be measured in our bodies. Those are just some of the examples of endocrine disruptors that we have seen have effects on animals and humans. Let's look at the immune system now. The immune system is a series of organs, and you can see which ones in the diagram at the right, as well as a series of cells and processes in the body that protect the host from viruses, bacteria, parasites, and even mutant precancerous, and I should say also cancerous cells. So the immune system is very important in maintaining your health. Particularly important are the white blood cells, for example, the T and B cells, which provide immunity from thousands of potential disease agents. And one of the primary responses of the system is inflammation, redness and swelling. When you get a cut and it gets red and heats up and swells, that is your body causing that response. Pathology of the immune system includes things like autoimmune disease, inflammatory disease, and cancer. I want to talk a little bit about some of the evidence that shows that toxicants can affect the immune system. The B lymphocytes of the immune system are able to defend the body against tens of thousands of different bacteria, fungi, and viruses. In order for the B lymphocytes to do this, they must be educated when young, and they do that in the bone marrow. Young B lymphocytes are very susceptible to the effects of pollutants, and two classes of organic synthetic chemicals cause B cells to initiate a suicide program. In other words, they kill themselves. And these are aromatic hydrocarbons, which are combustion products of fossil fuels, and phthalates, which we just talked about. And phthalates send the strongest cell death signal ever observed. So we were talking about phthalates as being a problem with the endocrine system, but here's an indication that they may also adversely affect the ability of the immune system to do its job. These kinds of toxic exposure have the potential to leave the body with insufficient cells to fight disease. As one recent paper put it, There is now compelling evidence that developmental exposure to chemicals from our environment contributes to disease later in life. And I would just ask now, how many of you have heard of this beforehand? Have you heard of this before? My guess is you haven't. It would seem like this should be the kind of news that we're hearing all the time, and we should be discussing as a society how we are dealing with the threat of synthetic toxicants. I want to also talk about asthma. You probably have all heard that asthma has increased in the last 50 years in the human population, particularly in industrialized nations. It is a large inflammation response by the immune system to non-pathogenic substances in the lungs. In other words, your body mounts an attack to a threat that is not real. The immune system should not be acting this way. Now, T cells, known as Treg cells, are responsible for preventing the immune system from overreacting when the threat is not real. If your immune system starts to react, the Treg cells are supposed to say, hey, wait a second, false alarm, everybody as you were. But a 2010 study from the University of California, Berkeley found that air pollutants suppress these Treg cells. So you can now see the problem with that, right? The lower function of the Treg cells means that asthma symptoms will be more severe. Once again, this is something that should be front page news and we should be hearing about on a regular basis until we resolve this. My guess is none of you have ever heard of this. Lastly, PBTs, remember them? Persistent bioaccumulating toxins. A 2019 study of mice exposed to dioxins, which we'll talk more about later, showed that these mice were less able to fight subsequent exposure to influenza virus. That's the flu to you and me. The researchers observed that the exposure to the toxins impaired the function of cytotoxic T cells, which are a white blood cell that protects against viruses and bacteria. Further, not only were the mice exposed less able to fight influenza, but their offspring were less able to fight influenza. And this effect continued through at least the great-grandchildren of the exposed mice. Now, this is exceptionally scary because it means that exposure causes something to happen in your body that then gets passed down. Once again, this should be front-page news, something you've heard about on a regular basis. Lastly, I want to talk about cancer and carcinogens. Cancer is a disease in which cells behave abnormally, in that they divide without control and they invade other body tissues. They're not supposed to be dividing, but all of a sudden they start dividing. Cancer is really dangerous because the tumors can spit out cells that are cancer cells that travel through the circulatory and the lymph systems and form tumors in other parts of the body. And this is known as metastasis. And when a cancer metastasizes, it has become much more difficult to treat. I don't know if you know this, but cancers are categorized by the type of tissue that becomes abnormal. So carcinomas develop from cells that cover the outer layer of the body, including the skin and the intestinal lining. Sarcomas develop from more internal tissue, the bone, the cartilage, the fat, the muscle, the blood vessels, and connective tissues. Leukemia develops from blood-forming tissues. Lymphoma and myeloma from immune system tissues, etc., etc. Cancer costs the United States annually a huge amount of money. A 2010 study said that about $102.8 billion in direct health costs due to cancer, $20.9 billion in lost productivity due to absence from work, and $140.1 billion in lost productivity due to premature death. This was a study done by NIH. 570,000 annual deaths, or about 0.2% of the population, dies each year in the United States due to cancer. The important thing you should understand about cancers, they're all caused by mutations of the DNA that causes the cell to divide, in other words, undergo mitosis, when it shouldn't be undergoing mitosis. Substances that cause cancer, we call those carcinogens. They are also mutagens because they have the ability to mutate DNA. Environmental exposure is responsible for 75% of the diagnosed cases of cancer in one estimate. 6% of cancer deaths are directly related to occupational and environmental exposure in another study. There is now a large list of substances known to cause cancer, And that's linked here, and you can look at that if you'd like. And finally, I want to point out that, once again, the apologists who say this is all people just overreacting will often say things that, oh, everything causes cancer in a big enough dose. That is simply baloney. Not everything causes cancer. We can screen relatively easy to see if something has mutagenic and carcinogenic potential and then act from there. Now, carcinogens, as I said, are mutagens. And that means that every exposure brings with it a statistical risk of the DNA mutation happening. Now, the immune system is fantastic because it has methods for eliminating mutant precancerous and cancer cells. And this reduces the risk of exposure to low doses. But these always don't work. And in fact, there are growing fears that it's environmental toxicants, which in some cases cause the immune system to fail in weeding out cancer cells and precancerous cells. In terms of determining safe levels of carcinogens, toxicologists look for the exposure rate at which no effect can be detected, and then the safe exposure level is set based on that. And I won't go into the politics of that, but I'll bet you that's an interesting story and one that should be talked about publicly on a regular basis. I want to do a review to ask you whether you think the connection between toxicants and cancer is clear. There are some naturally occurring carcinogens, but the quantity produced by humans and released into the environment since World War II is huge and unprecedented. Everyone is exposed to these chemicals. There is no escaping them, although lifestyle choices can change exposure. For example, eating organic food reduces your exposure, and not eating meat reduces your exposure because animals bioaccumulate more than plants do. You may hear an argument that says something like people are living longer so they have to die of something, and that something is cancer. Is this explanation correct? Is this why cancer has become so big? Well, no. The overall pattern is that cancer rates are increasing at all age levels, even though for some cancers the rate is decreasing, and this refutes that hypothesis. Lab tests show that animals get cancer when exposed to low levels of carcinogens in controlled experiments. Cell biology corroborates that mutagens alter DNA. So we have all the pieces in the model that say these mutagens can cause cancer. Is this enough evidence for you? Given that, there have been relatively few formal studies looking at synthetic chemicals in the environment and their relation to cancer rates. In other words, to me, this should be a national priority. So these novel chemicals are being introduced into the environment at unprecedented and, I think, alarming rates. In the US, the regulatory agencies, the EPA and the FDA, are overwhelmed and can't test them. And so as a result, they must rely on data supplied by the companies that wish to produce the chemical. Now, the history of chemical exposure shows that chemical companies will deny harm and fight efforts to investigate adverse effects of profitable chemicals. Wouldn't it be better, perhaps, to put off introducing chemicals until we know what their effects are? At any rate, how do you think this conflict of the public interest could be resolved so that public interest and public safety is guarded? What do you think would be the best way to move forward? So I hope you now understand what it means for a toxicant to affect the endocrine system, to affect the immune system, or to be a carcinogen. And I hope you understand some of the issues, and I hope you know some of the names of the chemicals that do this. In the next talk, we will talk about a whole smorgasbord of issues that come up as a result of what we've already learned. And we're going to start by looking at how can we make sense of the synthetic chemicals that we're exposed to on a regular basis. How can we categorize them and start to make sense of them? Until then, study hard.